This is the last video in the series where we end up with ViT for image classification. So as you can see on the screen, the code is very straightforward. We have already built our ViT model class. We just use that and add the MLP on top. The MLP on top is essentially our classification head. So the code looks like something like this, where we declare a ViT model, which is the class which we just built in the last video. We declare a classifier which takes in hidden dimension and gives out number of labels. Now, number of labels is something we set in the config. So I used the CIFAR 10 dataset. So I had 10 classes. I'd set my number of labels as 10 as well. If we go to the config.json, we can see that the number of labels is set to 10. Now I'll go back. In the forward function, we take the input, image input, we pass it to the ViT model, get the output, take the first index of that, since that will be the output, the rest of them are essentially scores. Now, classifier output is self.classifier of attention output, where we take all the batches and all the features of the first index. We take that out. That will be the classifier output. Now, we declare simple cross entropy loss, since it's a simple classification problem, and we convert both the classifier output and the labels to a compatible format to calculate the loss, since we are doing the dot view to essentially reimagine them as different tensors of different shape, so that we can do a simple loss calculation. Now, the final output is a classifier output plus output of 2 colon, where we can see what those are. So the main output which we are concerned with here is classifier output, since we have these flags here which are used to return scores and hidden states and things like that. We'll not worry about these for now. This is the main output. Now, what we do is return loss, comma, final output if labels is not none. So if we pass the model for forward propagation with a label, then we return a loss along with the output. Otherwise, we just return a simple final output. So that is pretty much it for the model. We finally have the model ready, and it was not as complicated as probably a lot of you might have thought. Now, I've written a simple data loader, and I'm not going to explain the code in detail since it's pretty straightforward. It's not really that complicated. And I'm giving you the link to my GitHub repo, which has all the code in the description, and y'all can check that and maybe use that as well. I'll just skim through the code so that it doesn't take you completely off guard. We create a data loader. We load the CIFAR 10 dataset. Now we declare a few set of transformations which the image needs to go through, like normalization and things like that. Now here, this part is, since I didn't really have a big GPU, I created a small subset of the dataset which I can train on just to see if the code is right and the model works and things like that. Then we create a dataset class which is inherited from torch utils dataset. All we do is update this get item function, where essentially we have an image and we have a label. Now we do this transformation to the image. What are the transformations we have defined over here? And we finally return the image and label every time get item is called. This entire thing, this class is declared for both train and test, and transformations need to be done for both. Now we return a data loader, we wrap these data sets inside a data loader and return that as outputs. So that's what this get CIFAR 10 data loader does. And the train function is also pretty straightforward. We import our ViT for image classification and our CIFAR 10 data loader function. Now we create an instance of the class of the model, and we decide our optimizer, which is AdamW here, and we create a simple train function. I mean train function which has a simple training loop where it goes for X number of epochs, where we keep updating the TQDM bar with the loss and the accuracy of the current epoch. And at the end, we can print what the running loss and what the training accuracy are. And if the validation accuracy is better than the best validation accuracy, we save the model as best model saved at epoch, and we print this best model saved at epoch. There's a simple validation function where we put the model to eval mode. We calculate the number of correct predictions and the total number of predictions, and we can essentially calculate the accuracy of predictions on our test set. All we need to do here is get CIFAR 10 data loader and then call the train function, pass the right parameters through it, and there you have it. That's pretty much it. This is how we train the model. When essentially we train the model, it opens up something like this, where we start training and we can print the losses and accuracies and things like that. It's pretty straightforward. I hope the series was helpful. I hope this series could help you out in some way in understanding how to read a paper, how to go about it, how to write code, how to write custom code, how to understand custom implementations of a lot of internal blocks in Torch, which you might not have been familiar with before. I hope this video is helpful. This is the end of the series. And yeah, that's pretty much it for this video.